Please do the warm-up as a group before watching this video, and then watch this video in case you have any questions. I'll walk through each of these problems. So pause the video now and do the warm-up as a group if you haven't already. Okay, so for problem 1, we are dividing by a monomial, so we can use term-wise division, which means we take each term divided by the denominator. So that's 5a to the 5th b squared divided by 5a squared b plus 15a cubed b divided by 5a squared b minus a squared b squared divided by 5a squared b plus a squared divided by 5a squared b. So reducing, the 5's reduce. This becomes a cubed on top, and this becomes b on top. So we get a cubed b as our first term. Reducing again, this is 3 in the numerator, a in the numerator, the b's cancel out, so this is plus 3a. And then we can see the 1, invisible 1 there, reduces to 5 in the denominator. A squared over a squared reduces to 1. B squared over b is b in the numerator, so this is minus b over 5. And then 1 over 5, again 5 in the denominator. A squared over a squared again reduces to 1. And now I have a b in the denominator. So remember, the numerator becomes 1, so it's plus 1 over 5b. All right, for number 2, we can't use term-wise division, so we can use either long or synthetic division. I'll show you synthetic division. So m plus 3 equals 0. M would have to be negative 3. We put negative 3 in the top box, and then we do our coefficients in descending order. Degree 3, degree 2, we're missing 0 m. So degree 1, degree 0. So we have 2, 3, 0, 17. Drop the 2, put my remainder box. 2 times negative 3 is negative 6. Adding 3 plus negative 6 is negative 3. Negative 3 times negative 3 is 9. 0 plus 9 is 9. 3 times negative 3 times 9 is negative 27. Plus 17 gives me a negative 10 remainder. So writing this as a polynomial, we went from degree 3, 3 minus 2, 3 minus 1 is 2. So this is degree 2. So we have 2m squared minus 3m plus 9, and then the remainder minus 10 over m plus 3. Or you can write it as plus negative 10 over m plus 3. And then we'll look at number 3. So in number 3, we just want to find the LCD. We do not want to solve. So the LCD, I'm looking at factoring each denominator, z minus 9. The second denominator is a difference of squares, so z plus 9 times z minus 9. And then the third denominator is just z plus 9. So the LCD is z minus 9 times z plus 9. And it doesn't matter if you put the plus or the minus first because it's multiplication. Okay, for number 4, we want to actually solve this one. So we said for an equation with fractions, the first step is to clear the fractions, which means we need to find our LCD. So LCD, this factors into 2 times 2 times 3, 2 times 3, and 3 times 3. So our LCD is going to be 2 times 2 times 3 times 3. So 4 times 9 is 36. Multiplying each term by 36, I get 36x over 12 equals, I'm not going to put an equals there, 36x over 12 equals 36 over 6 plus 36x over 9. So we get 3x equals 6 plus 4x. Solving for x, so minus 4x, we get negative x equals 6. Divide by negative 1, x equals negative 6. And then we need to double check that that doesn't make any of our denominators 0. Since all of our denominators are numbers with no variables, we know that it's okay. So x equals negative 6. Okay, number 5. We're going to do the same thing. We have fractions in our equation, so we want to multiply by the LCD. Our LCD here is x. So we multiply each term by x. X times x squared plus 4 over x equals x times 29 over x. The x is reduced. So we have x squared plus 4 equals 29. Minus 4, x squared equals 25. And then we can ask ourselves, what number do we know that squared equals 25? Or, more properly, we can subtract 25. And because this is a degree greater than 1, we know we need to factor. So x squared minus 25 equals 0. X squared minus 25 is a difference of squares. This is x plus 5 times x minus 5 equals 0. Then we know x plus 5 is 0, or x minus 5 is 0. Minus 5, x is negative 5, plus 5, x is 5. So we have x can be 5 or negative 5, but we need to check them. So we check our denominator of x. If it's 5, it's not 0. If it's negative 5, it's not 0. So both of these answers are okay. Okay, now I want to finish the last couple of examples from the 5.5. This is the 5.5 notes packet. So if you need to get that out, go ahead and pause the video. I'm still going to leave the try this for you to solve, and you can collaborate on that with your group. So we're going to look at example 7. For example 7, again, just like in the warm-up, we need to multiply by the LCD. So this one factors x plus 3 times x minus 3, multiplying everything by x plus 3 times x minus 3, which is my LCD, to each term. Okay, now I'm going to start skipping that middle step where I write out the distribution, and I'm looking at the x minus 3 will cancel. So I'm left with 2x times x plus 3 plus, in my second term, both pieces of the LCD, both factors will cancel. So I'm left with 6 minus 2x equals. Now my third term, the x plus 3 will cancel. So I'm left with just x times x minus 3. Okay, you can still work on that middle step if it helps to see that written out. And then distributing 2x squared plus 6x plus 6 minus 2x equals x squared minus 3x. I'm going to bring everything over to the left-hand side, so minus x squared plus 3x minus x squared plus 3x, 0 and 0. So I get x squared. Now I have 9x and a minus 2x, so that's plus 7x plus 6 equals 0. From here we need to factor, so what two numbers multiply to 6 and add to 7 are 6 and 1. X plus 6 times x plus 1 equals 0. Set each of those factors equal to 0. X plus 6 is 0, x plus 1 is 0. So minus 6, x is negative 6. Minus 1, x is negative 1. And then we check. So remember our restrictions here are that x cannot equal negative 3 or positive 3. Since our two answers are not plus or minus 3, we are okay. So x equals negative 6 and negative 1. Okay, again, pause the video, do the try this with your group, and then resume the video for the next example. Example 6, we're doing exactly the same thing. We need to first factor. So we have 2z squared plus 3z minus 2. What multiplies to negative 4 and adds to 3 is 4 and negative 1. 2z squared plus 4z minus z minus 2. GCF is 2z times z plus 2, negative 1 times z plus 2. We're not done. We still need to factor out that GCF, z plus 2 times 2z minus 1. So this factors into z plus 2 times 2z minus 1. Here I have 2z, and here I have z times z plus 2. So what is my LCD? Well, my LCD is z plus 2 times 2z minus 1 times 2z. Z is already included, and z plus 2 is already included. So my LCD is these three, well, really 4 factors, because 2 times z is 2 factors. Multiplying through by the LCD, z plus 2, 2z minus 1, 2z, distributing to each of those three terms. So my first 2 factors of my LCD will cancel out with my first term, and we're left with z times 2z minus. The 2z will cancel out with my second denominator, so I have z plus 2 times 2z minus 1, which if you recognize, that's our first denominator, equals, and then here the 2 does not cancel, but the z does, z and z plus 2. So we have 3 times 2z minus 1 times 2. And then distributing everything through, so 2z squared minus, distributing here, 2z squared minus z plus 4z minus 2 equals, I'm going to multiply the 2 times 3 first to get 6, and then distribute that, so 12z minus 6. Distributing the negative and collecting like terms, we get 2z squared minus 2z squared. This becomes a plus 3z minus, so minus 3z minus 2. Distributing the negative becomes plus 2 equals 12z minus 6. 2z squared minus 2z squared is 0. So let's do plus 3z plus 3z plus 6 plus 6. These cancel, these cancel. 8 equals 15z divided by 15. 8 over 15 equals z. And then we have to check. So this tells me z cannot be negative 2. 2z minus 1 cannot be 0. So 2z cannot be 1, so z cannot be 1/2. And here z cannot be 0. This is none of those, so this answer is not extraneous. That's our solution. Okay, go ahead and do the try this, and then we will look at the 6.6 packet, the new packet. Okay, 6.6, we're looking at rational equations and problem solving. So we're using what we just reviewed from 6.5, equation solving, and then also looking at that with word problems. So remember, solving for a variable means to isolate the variable. These are the steps that we've been using to isolate that variable, so they're written out again for you. And then remember, the word rational means fraction. We said anytime we see the word rational, we think fraction. A ratio is a fraction of numbers or quantities. So it's when we're relating to numbers or quantities. So something like 3 to 5, which can also be written as 3 over 5. Okay, and then when we set two ratios equal to each other, we call that a proportion. So that would be something like 3 over 5 equals x over 7. That is two ratios set equal to each other, so it is a proportion. Another example of a proportion here, what we can do is we can actually multiply 7 times x and 4 times 5, and we call that cross multiplying. So we can cross multiply, which is actually the same as multiplying by the LCD, because all you're doing when you cross multiply, when I multiply 7 times x and 4 times 5, I'm really multiplying by 28, but the 4 reduces with the first fraction and the 7 reduces with the second fraction. So let's look at this. If I cross multiply, which is multiplying across an equal sign, I get 7x equals 20, then divide by 7, x equals 20 over 7. Because my denominators are numbers, I'm okay with that. The answer is not extraneous. Or x over 4 equals 5 over 7. I can also multiply just both sides by 4. X equals 5 times 4 is 20 over 7. Okay, so all the methods that we've talked about still apply, but now we're going to apply them to equations that might have multiple variables. So in example 1, I have 3 variables and I want to solve for x. Well, the first thing that we need to do is we have to make sure that we clear all of our fractions. So we're going to multiply everything by our LCD, which is x times y times z. Distributing to each term, x reduces, so we have yz plus, y reduces, we have xz, equals, z reduces, we have xy. We want to solve for x, so we need the x's to be on the same side of the equation. So we can subtract xz. We get yz equals xy minus xz. Now we have x in two different terms and we want only one x. So the way we can do that is we can factor out that x as our GCF. Our GCF is x. So we write this as yz equals x times y minus z. And then we can divide by y minus z. Now here we subtracted because xz was attached to yz by addition. Here we divide because x is attached to y minus z by multiplication. So we get that x equals yz divided by y minus z. Okay, so that's how we solve for a variable. The same steps as before, but now we might need to factor in order to get one of our variables isolated as one of our steps. Okay, example 2. If a certain number is subtracted from the numerator and added to the denominator of 9 over 19, the new fraction is equivalent to 1/3. Find the number. So the first thing we want to do is we want to define our variable. X is a certain number. And then what is that number doing? Well, it is being subtracted from the numerator and added to the denominator of 9 over 19. So we started with 9 over 19. Then we subtracted this number from the numerator. We added it to the denominator. And the new fraction is equivalent or equal to 1/3. And we want to solve for x. So I'm going to cross multiply. So we have 3 times 9 minus x equals 19 plus x. Distribute the 3. So we have 27 minus 3x equals 19 plus x. Isolate x, so plus 3x plus 3x minus 19 minus 19. Those cancel out. 27 minus 19 is 8 equals 4x. Divide by 4. 2 equals x. Check back. 19 plus 2 is not 0, so then we are okay. The number is, the number is 2. Remember, for word problems, we want to write our answer as a statement back. Okay, pause the video and do the try this with your group, and then resume the video when you're ready for example 3. All right, in example 3, we're looking at 7 out of every 25 homes are heated with electricity in the United States. At this rate, how many homes in a community of 36,000 homes would you predict are heated by electricity? So we're looking at a ratio, 7 out of 25, and then we want to set it up as a proportion, so we have some unknown number of houses out of 36,000. So let's first define our variables. Question is how many homes? So we can say x is the number of homes. Okay, and that is the number of homes in a community of 36,000 homes that are heated by electricity. So I'm going to say number of homes, electricity. Okay, now we know 7 out of 25 is the ratio that we are looking for, equals our unknown number of homes out of every 36,000 homes. So how do we set this up? Well, this is like electricity over all. So 7 out of all 25 homes have electricity. How many have electricity out of all 36,000 homes? And then we can cross multiply, or in order to isolate x, we could also just multiply by 36,000 on both sides. Okay, so we have x equals 7 times 36,000 over 25, and put that into the calculator, and we get 10,080 homes. Okay, double check, 10,080 is less than 36,000, so that makes sense. So the answer is 10,080 homes would be heated by electricity. Okay, again, pause the video and do the try this with your group. All right, example 4, we call this a work problem. Okay, so this is a type of problem. Just like distance, rate, and time is a type of problem, this is a work problem. So Melissa can clean the house in 4 hours. Rachel can clean the same house in 5 hours. They've agreed to clean together so that they can finish in time to see a movie on TV that starts in 2 hours. How long will it take them to clean the house together? Okay, so the question is, how long will it take? So X is number of hours to clean together. That's our unknown. Okay, well, if my X is a number of hours, then I want to rewrite how much Melissa can do so that I can multiply it by hours. So if she can clean the house, Melissa can clean the house in 4 hours. That means she cleans 1/4 of the house per hour. So M cleans 1/4 of the house per hour. And then we want to do the same for Rachel. Rachel cleans the house in 5 hours, so Rachel cleans 1/5 of the house per hour. Now the reason we want to set it up this way is because now I can say how much of the house will Melissa clean in her number of hours. Well, she will clean 1/4 times X. However many hours she'll clean, so if she was cleaning for 2 hours, she'll clean half of the house. Same for Rachel, she will clean 1/5 of the house times X, the number of hours that they clean together. And our goal is that together, so 1/4 X plus 1/5 X, they will clean the whole house. Well, the whole house is 1 out of 1, so I want this to equal 1. So now again, we have an equation. It has fractions, so we want to clear them. So we're going to multiply by the LCD, which is 20, to each term. So we have that 5X plus 4X equals 20. So then combining like terms, 9X equals 20, and X equals 20 over 9. Okay, now we want to know, will they finish before the movie starts? Well, 20 over 9 is greater than 2, so they will not finish before the movie starts. So it will take 20 over 9. Let's write it as a mixed number, because when I say how long will it take, I wouldn't tell you it takes 20 over 9 hours. I would say that this is 2 and 2/9 hours. So it'll take 2 and 2/9 hours. So they will not catch the movie. Okay, go ahead and do the try this with your group, and then we will resume with example 5. All right, this is the last example for this notes, and this is a distance, rate, and time problem. The difference is now we aren't given times or distances necessarily as a number, but as a ratio. So Steph takes 1.5 times as long to go 72 miles upstream in her boat as she does to return. If the boat cruises at 30 miles an hour in still water, what is the speed of the current? So we're going to set up our rate times time equals distance table. And then we have our upstream and our downstream. Remember, if I'm going upstream, I'm going to be slower. So this is X minus C and X plus C. And I'm putting those in there just as a reminder for now. Okay, so we say Steph takes 1.5 times as long. So what we can say is that in order to set this in, it's not in hours, we can do our units as 1 unit of time as the time that it takes Steph to go downstream. And it takes her 1.5 times that long to go upstream. So we're going to say downstream is 1 unit of time, and upstream is 1.5 units of time. Okay, so since it's just that many times as long, we can put that as our upstream time and our downstream time. How far is she going? Well, she went 72 miles, so 72, and she did the return trip, which is 72 miles. And then we know the boat cruises at 30 miles an hour in still water, so that's our X value. Remember our initial rate. So this is 30 minus C and 30 plus C, where C is the current, or the rate of the current. And then we can set up D equals RT. So since my distances are equal, then R times T is equal. So we have 30 minus C times 1.5, I'm going to write as 1.5, equals distance equals distance. So rate times time equals rate times time. 30 plus C times 1. Distributing, 30 times 1.5 is 45, minus 1.5C equals 30 plus C. Distributing the 1 does not change our values. I want to isolate C, so I'll do plus 1.5 plus 1.5 minus 30 minus 30. Cancels, cancels. So I get 2.5C equals 15. Divide by 2.5. 15 divided by 2.5 is 6. And then double check logically, does that make sense? Yes, the current should be slower than the boat. So we say the current goes 6 miles per hour, or the current is 6 miles per hour. Okay, go ahead and try this. Remember, we can choose if our time is given as a percentage or as a ratio of time. We just choose the other time to be 1 unit. Okay, once you finish the try this, do your conclusion, and then you can start working on the Math Excel, which should already be posted. If you have any questions, you can always email me and I'll get back to you. But we will go over the answers to the try this, and I'll answer questions next class. Next class is our review class before the test. Your test, remember, is on Friday. So your Chapter 6 review packet is due next class along with the Math Excel. And then the test will be Friday, and there will be another review assignment from Wednesday, which will be on Math Excel. Okay? If you have questions, you can always email me, and I should be back to school hopefully tomorrow. Thank you.